In this example, we are given two vectors in their standard unit form, and we are asked to compute the dot product between these two vectors and to also find the angle theta between the two vectors. So here we are given vector v, so I'm just going to rewrite this in its component form, v sub 1, v sub 2, and that's 8 minus 1. And then we have vector w, so w sub 1, w sub 2, and that is negative 1, 8. So for part A here, we are looking to compute the dot product. So here we can use that first definition. So actually we'll make this v and w, and we're using that computation definition. So we have vector v dotted with vector w, and that's v sub 1 times w sub 1 plus v sub 2 times w sub 2. And remember that this is a scalar or a real number. So plugging our values in, we have v dot w is equal to 8 times negative 1 plus negative 1 times 8. So we have minus 8 to leave us with negative 16. And now for part B here, we want to compute the angle between these two vectors. So let's say if this is our vector v, and this is w, obviously not drawn to scale here, but we want to calculate the angle between those two vectors. So here we're using that alternative form of the definition, our geometric interpretation, that v dot w is equal to the magnitude of vector v times the magnitude of vector w multiplied by cosine of theta. And we'll use this definition to solve for theta. So here I'm going to calculate the necessary components first. So we already know from part A here that vector v dot vector w is equal to negative 16. We're also going to need the magnitude of vector v, so that's the length here. So we have this square root of 8 squared plus negative 1 squared, all under the square root. And we have the square root of 64 plus 1, which gives us the square root of 65. And there's no perfect squares within that radicand, within the products of, or the factors of 65, so we can leave it as it is. And then computing the magnitude of vector w, here we'll have the square root of negative 1 squared plus 8 squared. And that's equal to the square root of 1 plus 64, which again gives us the square root of 65. So we can actually even take this one step further and say the product of these two magnitudes, the magnitude of vector v times the magnitude of vector w, gives us the square root of 65 times the square root of 65, or the square root of 65 squared, which simplifies to 65. So we're going to use the dot product here, right, which we see on the left-hand side of our equation, and we're using the product of the magnitude of these two vectors, which we see on the right-hand side of the equation, to help us solve for theta. So we're plugging those values in. So we have negative 16 is equal to 65 multiplied by cosine of theta, and now we're ready to solve for theta. So we'll divide both sides by 65 here, and I'm actually going to bring cosine to the left-hand side and say that cosine of theta is equal to negative 16 divided by 65. And then to solve for theta, we want to go ahead and get rid of cosine. So the only way to do that is by applying our inverse cosine. So we take the arc cosine or inverse cosine of both sides here, And what that does is the arc cosine and cosine invert each other, or they undo the effects of each other. So we're left with theta is equal to inverse cosine of negative 16 divided by 65. And this is radians here. So if this question was to appear on our exam, this is where I would want you to stop. But let's say that we are asked to round our answers to the nearest decimal, rounding to the 10th place. So we can substitute this into the calculator. The one time I'll let you use a calculator. And if we plug this into our calculator, we're going to find that theta is approximately equal to 1.81950. And again, we want to round to our 10th place here. So we can say that this is approximately equal to 1.8 radians. So then just be mindful, is the question asking for your degree in radians, or is it asking for it in degrees? So let's say if it wanted our solution in degrees, right, we want to make sure to change the mode on our calculator. So plugging the same cosine or inverse cosine of negative 16 divided by 65 into the calculator for degrees, theta is approximately equal to 104.25, and again rounding to the 10th place. So we can round up here and say that theta is approximately equal to 104.3 degrees. But again, this is the first box solution here. This is how you would leave your answer on our exam.